Good evening, my dear students. Can you please switch on the camera? Hello. Yes. So today is our first class, no, for physics. Okay, dear. So let us introduce ourselves. I'm your physics teacher and my name is Nazneen. Okay. So we will introduce ourselves. Jovida Shri. I will unmute. Please. Good evening, dear. How are you? Fine, thank you. So, tell about yourself. Where are you living and where are you in India? Yeah. Okay. And who all are there in your family? Parents? Ah. Okay, dear. Okay, thank you. Then we have Arushi. Arushi? Yeah. Hi. How are you, dear? Fine, thank you. Okay. So, where are you from India? Okay, dear. Are you using this app for the first time or you're no, you? Yeah, in the other classes. Okay. So, school started for you? Yeah. Okay, dear. Okay. Okay. So, this is our first session. Okay. So, let's start. Okay, so we'll start with the class with some important instructions that you need to follow during the class. Okay. Okay. So all these you might be knowing, but still let's just introduce something. Okay, so you need to keep your camera switch on for whole session. Okay, and for physics you should have a notebook with you, pen case, water bottle and all. So if you are using a mobile or a tablet, please put it in the this side. You have to portrait format. Okay, so no, landscape mode, so that you can visualize your classes so smoothly. Okay, now if there is any exam session, you have to attend it mandatory, and you need to be motivated and be enthusiastic in the class. Okay. Okay, so fine. You have to study every day the lessons that teacher take in the class. Practice makes man perfect, no? So you do your homework, practice your problems. We know that we are in 9th class. Physics is having lot of problems, no? So we need to practice that. Okay. Eat healthy food. It is 6 o'clock in your place, no? After school have healthy food to get energy, and so that you can work out your brain. Now drink water. How many glasses of water you have to drink? 8, no? Okay. 8 glasses of water. And 8 hours of proper sleep. Okay. So you are children, so you need to work out and grow. Okay. Now, if you have any queries, please raise your hands. I will unmute. And if something is being asked in the class, you can just put in the chat. Okay, that is fine. Okay. So before starting the class, I wanted you to welcome officially for my physics session. So this is our first session, and we can start together and learn together. Okay. Now, this is our thought for the day. Anyone can read this? I will give chance to Jovida Shri. Okay, unmute. Can you read this, my dear? Yes. Yeah. What is the meaning of that? Yes. Yeah. things. Yeah, very nice. Exactly. Okay. So not only today's bad things, we don't have to carry all the baggages from like months and years. No? So today should be a fresh day for you. Okay? Or this moment. Every moment is a blessing to you. Blessing from the God. So we should start like that. So see, you are getting enough facilities, no? To acquire knowledge, to get knowledge. So in our times and all, we didn't have such as like this internet facility. So we are improved in technology and we can share everything to you. So this technology is like in our fingertips. So that is also a blessing. So we should forget everything that has happened. If it is trouble, okay, good memories you can keep and wipe out all the bad memories and start a new day. So this is also our new day, no? Our session is also a new day. Okay, very good. Okay, now before getting into serious class, I wanted to do a brain gym activity with you. Okay, so this is say the color of each word. Teacher will explain one word. So which is the first word written? It is black. But you should not read it as black. You should read it as red. Okay, that is the game. That means you need to read the color of the font. Okay, that written word color only you should read. You should not read the word. So next word what you will read? You will read it as black, not white. Okay, so how much you can do, that much, till that is a game. Okay, so I will give first chance to Arushi. My dear beautiful girl, come on, try it out. Yes. Yes. Ah. 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 Come on. Ah. Black. Ah. Ah. Red. Very good. So kudos. Okay. So Jovidashri also can try. I'll unmute. Okay. Try, my dear. You cannot admit. Okay, dear. Come on. Try. You are unmute. You are mute. I'm asking you to unmute. Yes, yes, you can. You can. Yes. Yes. Yes, very nice. Okay, so why did teacher make you play this game? Did you understand? What is this game all about? This game is a brain teaser, or we can say this is a brain gym activity. Okay. So while brain gym activities are very important, if you do it on the daily basis, you will get in internet a lot of brain gym activities. Okay. So if you try to do it like on the daily basis, it will be very effective for the expansion of your brain, and you can memorize well. So here see this, your eyes and your brain is working together. Your eyes will see the color, okay, and what your brain will see, brain is going to read it as black, but your eyes first visualizes a color only. So the game is both should come together. So you should read it as red, even though your brain is telling you to read it as black. Okay, so that is the game about, just a brain gym activity. So you can practice this at home. It helps you a lot. Okay. Okay. Now getting into the serious session of our class. You know, science is divided into different branches. Okay, out of that, one of the most important branches is physics. And out of so many chapters, our chapter 8 is a physics chapter, and the chapter name is Force and Laws of Motion. Clear? Force and laws of motion. Force, I know, you know, everybody knows what is force, what is motion and all. So we are going to introduce some laws of motion in this. Okay, law. So theorems and law is very important. Based on that only physics is dealing with. Okay. So I wanted to know what is physics actually? What is a subject physics? So you can write your answers in the chat box. What do you think is physics? Just tell what comes in your mind. Even if it is wrong, it is okay. We know. We cannot have we don't have to by heart equations. We can say equations. It is full of equations only. Then, by the word meaning, why we say physics is a branch of science? Study of science of force or sound waves. Yes, clear. Yeah. One point is correct. Is it only about force or sound waves? Yeah. Concept of force and sound waves comes inside physics. Okay. We know that biology is dealing with living organisms. Whatever living organisms, we put it in biology. Whatever chemical reactions happen for solid, liquid, gases, that comes in chemistry. Now, what is physics actually? We know that we have learned from the first class onwards that every organisms or every objects or anything is made up of matter. Okay? So, if teacher is like, if you have doubts, or if you wanted to say something, just raise your hands. And if it is okay what I am telling, just put a thumbs up. Okay. So what was you telling? I was telling that every thing is made up of small particles that is called as matter. So physics is all about what? Energy. Matter, energy, force, pressure, all those things. Okay, so everything, all these concepts come under physics. Okay, so as a definition, what we can tell? We can tell that study of matter and its motion. So what is motion? That all we will learn in this chapter. Okay, along with some related concepts such as energy, force, as she said, as Arushi said, sound waves. Everything, those such concepts comes under physics. Okay. So our chapter is what? Force, laws and motion. So in today's class, teacher is going to tell a story. I'm going to introduce 5 important terms or keywords. So I will be using this word, keyword. Okay. So these 5 keywords teacher will introduce that you already know. But you just know the meaning, but you don't know how to relate it. Okay, we know actually, but in words it is difficult to say. Okay, so through a story I will explain those words. So what are those words? Okay, the first word is object. Second word is force. Third word is motion. Fourth one is direction. And fifth word is magnitude. So, in today's class, we are gonna cover all these. So, you might not know, maybe you know the definitions of these things. So, each one we will check out, okay, through a story. So, what is object first of all? What is object? Is it living? No need. You need not write these, okay? I will tell which all things to write. This is just a recap session, okay? Non-living thing. Yes, correct. Why it is called non-living thing? Why it is called non-living thing? An object. So, for example, my pen. It is an object, no? It is non-living thing. Why it is called non-living thing? What property of this makes it non-living thing? So many properties are there which differentiates. It doesn't function any living activities. So what are these living activities? Jo Vidashri. What are these living activities? Respiration. Yeah. All those things, no? Respiration, reproduction, movement. Okay? So, all these things are living activities. Now, a pen is an object. Why? Because it is a non-living thing. It cannot move. Yes, it is stationary. Yeah, it is this is stationary. Stationary. Why? Because it cannot move by its own. Okay. So, what we need to do? Arushi also can respond your answers. Okay. It is moving with the help of my hand. Okay. The pen is moving with the help of my hand. Understood? So, why we call this pen an object? You understood? No? Okay. So, teacher is gonna tell a story. We have a ball. So, what is ball? Is it an object? Yeah, it is an object. Okay, ball is an object. Why? Ball cannot move. Can it roll on the floor by its own? No. But if it is a small ball, by wind, it can move. But I am telling a big ball. You used to play football, no? Yes. So, this is an object. So, ball is an object. Okay, clear? Now, I wanted to move it. So, what activity I can do? What activity I should do? Kick it. Very good. Okay, Arushi, getting? Kick it. So, how do we kick it? With our legs. So, I can consider myself as an object also. I am a living object. Okay, and ball is a non-living object. I use my leg to move or to kick the ball. So what happens there? The ball will stay there? No. The ball will stay there. Will it stay there? No, it will not stay there. It will move. Okay, it will move. So that is called as motion. Understood? That is called as motion. Motion is what? The process of moving from one place to another. So as physics students, should we say it as movement or like moving or no? We should use the word motion. What is that keyword? Motion. So object and motion you got. Object means it can be either a living object or a non-living object. Okay. Now in our case, ball is an object, that is a non-living object. And we are using our leg to kick it. Okay. And the ball is moving from one place to another. That is called as what? Tell me. Arushi, tell me, what is that process called of moving? Moving from one place to another. What is that? Motion. Very good. Okay, so understood. Now I am kicking the ball. So what process I am doing? How can I kick the ball? Using my legs. Okay, using my legs. So that process is known as what? It is force. Okay, it is force. Very good. Very good. So we have heard that in smaller classes, what is force? Tell me, it is push or pull. Okay, force is push or pull. So you might be confusing what is push and what is pull. Every time in some doors, if it is written push or pull, you get confused, no? Now from now onwards, you should not get confused. You should be thorough, or you should be clear what is push and what is pull. So teacher will tell you what is push and pull. And that push and pull is known as force. Okay, so teacher will draw a diagram so that you will understand little more. So what do we have now? A ball. Okay, so this ball is an object and we have a child here. Okay, and he is using his leg to kick this ball. Okay, so the ball is what? The ball is the object. Okay, the ball is the object. So we can say the child is also an object, that is a living object which comes here. Now what he is using? He is using his leg to kick the ball. So here what happens? Force is applied. Okay. So force is applied. Understood? So if I am telling that I wanted to move this pen. Okay, just simply if I look it will move? No. I should use my finger or hand. I will just touch it. Will it move? Will it move? No, it will not move. Yeah, very correct. So it will not move. So I should apply force. See, that application of is known as force. So what I am doing? I am pushing. Okay. That is away from my body, and pulling, that is towards my body. Clear? Okay. So any activity, any task, we know that our is a living world. So we have lot of activities: kicking, walking, rolling, lifting. So on the table we have a pen. So how I will take it? I can take it by lifting. Okay, so that is also one action. Without applying force, I cannot take. Okay, so lifting is also one. I can move the pen on the table. That is also force. Okay, so here in this case, the force is applied on the non-living object, that is the ball. And what happens to the ball? Will it stay there? No, no. Will it stay there? No. What happens to that ball? It will move. It will move. Okay. From this point to where we have pushed this. Okay. Now my question is, now teacher has drawn that arrow. Okay. Why teacher has drawn that arrow to that side? Which side is that? Is it right or left? Tell me. Arushi, which side is that? Okay, for you it is left. The fourth, okay. See, for me it is right, I think. It is right, no? Okay, so teacher has put that arrow that side. Why the ball is not going to the left side? Why the ball is not going to the left side? Yeah. Jo Vidashri has told me that the force is applied in that direction. Yes, very good. So did you understand the connection between direction and force? That is, to which area, to which position I am applying the force, to that position only the object will move. It will not go the opposite side. Okay. So that is a common sense, but we need to relate these things. Okay. So motion understood. moving from one place to another. How? By application of the force. Okay. Now, to which direction? To the direction of the force applied. To the direction to which we have applied the force, that is called that direction. Okay. So, the direction of the motion and the direction of the force should be the same. It will be the same. Should be, no? It will be the same. Okay. Now, consider, can we have opposite direction force? Yes. There is a chance where the force is applied to this side. So, if the ball was here, if the person is kicking from this side, the ball will go this side. So, to the left. So, understood, no? Okay. Now, next I want you to think that I wanted to move a book on the table and kick a ball. Okay. So, consider this is my book. I am putting it in on the table and I want to move it. Okay. And at the same time, I wanted to kick the ball also. Which force is greater here? Is it same or is it different or greater, lesser? The ball. Why? The ball is heavier, we know. So, just like touching with a fingertip, it will not move. So, you need to apply more force. Okay. So, that measure of the force is known as magnitude. Got it? Okay. Measure of the force is called as what? Magnitude. Okay, magnitude. So, for example, I wanted you to draw a line on the notebook. Okay, one line. So, what you will use? Which instrument you will use? Ruler, scale. Yes. What is the unit of length? You know that is length. What is the unit of length? Centimeter, meter, yes. Kilometers. Same. Similarly, force is also having a unit. Okay. So, force is measured in terms of magnitude and it has a unit, and that unit is known as Newton. Okay. What it is? Newton. Okay. So, it is named after our famous scientist Isaac Newton, because he has proposed many important laws inside the topic force. Okay, force and motion. Okay, so that's why we named it after him. Okay, and the unit is represented as N. Capital N. Clear? Capital N. So, in coming like topics, we will learn more about it. You don't have to write it down. So, now teacher's story is clear. Every 5 words we introduced. Okay. Once more we will revise this, because this is like a base of this chapter. So, what did you understand? We have an object. To move that object, we applied force, and the movement is known as motion. To where it moved, to the direction where the force applied, and how much force I applied is known as magnitude. Okay, magnitude is measured. Force's magnitude or force measure is represented in Newton, and it is capital N. Okay, so you should not write small n and all. That is all. So, physics, very particular that laws, keywords, everything should be same. Accuracy. So, matters in physics. No, when I asked about physics, you told no that it is full of equations. So, in that equations, the most important thing is that we need accuracy and precision. Accuracy means correctness. So, we for writing units, you get marks. You know that. Yeah, proper unit. Sometimes in some questions they will tell us to represent in meter per second or centimeter per second, like that you will be learning. Okay, so that time you should write, if the answer is 5, you should write 5 centimeter or 5 meter. It depends upon the question, okay, or the units given. So that unit, no, if I am not writing centimeter, teacher can ask what 5, what is 5 here? 5 centimeter. So that is clear. So for unit you get half marks or 1 mark, depends upon the question. Clear this? So this much understood, no? Okay. Now this keywords, don't forget why I am talking about the keywords is that any definition, any definition, if you have been asked to write, if you remember these keywords, it's easy. You can relate it. Okay, you can relate it with your other words and make it a sentence. Okay. Okay. So we were talking about motion. We need to know what is motion, how to define it. Teacher already told that movement or moving an object from one place to another is known as motion. Okay. So please take out your notebook, write today's chapter name. What is our chapter name? What is our chapter name? Force and laws of motion, chapter 8, and write this definition. Then teacher will explain what is it. Okay. Take out your notebook, write motion as a heading. Motion is a phenomenon in which an object changes its position over time. Okay, after finishing, please show a thumbs up, my dear girls. Write it beautifully, legibly, neatly. Yeah, okay, dear. Finished? Okay, I'll give time for Arushi to write. Done? Yeah. Okay, my dear. Okay. So, what did teacher tell? Motion. What is phenomenon? Here we have written, no, phenomenon. It is just simple process only. Okay. It is a process. What is motion? It is a process in which an object changes its position. Okay. What is position? What is position? In a previous example, yeah, in a previous example, you can see here, no, a ball is moving from this position to this position. Okay, now after kicking, what happens? The ball will reach here. Okay, so the position has been changed, no? The position has been changed. Okay, so one position to position. Now, over time. Over time. Now out of this, how many keywords you can spot out? We have already learned what is motion. Then we have learned object. Then we just now we learned position and what is time. Okay. So if you learn these keywords, okay, then you can connect it. Just think the example of the bowl. Okay. Now, what is over time? Over time means for how much time it will take for a ball to move from one position to another. That is time. Okay, so if there can be some questions like this, asking about there will be an object. Okay, the object was here, that position is known as the start position. Okay, I kicked the ball, so it moved to the other end, that is the end position. Okay, and how much time, how much time it required. So questions answer you get it from the definition itself. Okay, so motion is a phenomenon in which an object changes its position over time. Okay, over time. Clear? Okay. So what is this picture? What is this picture? All the cars are still. They are. What happened? See how many lanes? It is Dubai. Somewhere in GCC, I think. Big roads and traffic. Lot of cars are in movement. We will tell. Should we tell movement? No. Motion. Yes. Yes. Okay, my brilliant students know that. It is physics student, no? It is cars are in motion. Okay. Okay. So we will see a video now. From the video, what did you understand? I'm not going to switch on now. Tell me, what did you understand from this? Just a picture. What is that person doing? You know cycling? You people know cycling? Everybody? So he is cycling. Okay, a moving cycle. Okay. So how to move a cycle? Pedal. Very good. Jovidashri. Pedal. So that cycle movement is known as pedaling. Okay. We use that pedal and moving. Simply can we move it just by feather touch? No. We should apply what? We should apply on the pedal what we should apply? Force. Very good. Very good, Ayushi. So force we need to apply. If you are applying force, it will move forward. Consider I am moving below a hill, like slope. Okay. So what do you think the speed of the cycle will be? Like moving down a hill. What will be the speed? It will be faster than the normal road, or it will be like slower. Fast. It is very dangerous also to come down a slope. Okay. So what you will do? What you will do to reduce the speed? To reduce the speed of the cycle, what will you do? Brake. One is brake. If you apply brake, it will stop. No. I don't want to stop my cycle. I want to like reduce the speed. Yeah. You can slow down the pedal. That means the application of force. Okay. How can we slow down the pedal? You just leave your leg a bit. Okay. And you apply less force, or just move. Don't move your legs. Just put on your pedal and thus it will go down. And for a safety, you need to apply little brake too. Okay. So what will happen? It will slow down. Now consider another situation, that is you are going up the hill. You are going to climb the hill. So at that time what we should do? You are going to climb, or your car is going somewhere on the hilltop. Pedal faster. So what is the force applied there? Faster pedaling. More or less? More force. Okay. So as we apply more force, that time don't put the brake. It will slow down again, and you just, if it is like climbing, you go down. You have seen that game, no? One person riding a truck over like a hill. You should apply the accelerator. It goes but then too, if you keep on pressing that accelerator, it will not go, it will come down, like tumble up and down. Okay, so all this is physics only. Okay, now understood. So now we will watch the video and just watch it clearly. Something is gonna happen now. See how fast he was going. Now see. Now what happened? Now what happened? Yeah. Now what happened? See? And there is an arrow backward. That also see, okay? Now here's again. Understood? Understood. So you told, no, you will, like when you wanted to slow down, or if your legs are paining, you usually stand like that on the pedal. Just touch it. So it will go. That motion it will go. So understood? Force is there, motion is there, object is our cycle. Okay? Object is our cycle. And direction also you understood. You apply like this, it is going like that. But why there is a back arrow? Why there is a back arrow? When you slow down, there was a back arrow. Okay? So that's what we are going to learn next topic. Okay? Before that, I wanted to ask some more questions to make sure that you have understood the concept or not. Okay? So the question is, I have a ball. Wait, my dear. Okay, I have a ball. So this is my object. I wanted to move it. Okay, I wanted to move it. Can I move it if there is, if I am not kicking it? If I am not kicking it, will it move? No. So you should understand that for an object or a non-living object to move, there should be at least two objects in action. Okay, I said no, ball is an object and me myself is an object. So two objects, when they come into action, force is being applied and there will be motion. Okay, so we have to tell that there should be at least two. So what is that? At least two objects. So what is at least two? At least two means more than two or equal to two. So we can write mathematically like this: greater than or equal to. Okay, that is at least two. So if teacher is telling that for exam, at least 2 pens you need to bring. Or your mother used to tell, no, remind you, at least 2 pen you take it. That means 2 and more you can take, not less. So for a force to be applied, force to be applied or force to be come into action, there should be two objects, at least two objects. There can be more. There can be more. How it will be more? Tell me. One example can you give? Just think where a force is being applied where there are three objects, including us, who is going to apply, and the object. Wind, friction. Okay, friction also two objects, no? One surface and the thing. Okay, friction as a whole we can tell. But one simple example like kicking the ball, like that one activity, can you tell me? You kick another ball, 2 balls. Or I will say, just consider there is a gift box. Okay? There is a gift box and my Arushi is here and my, what was your name? I forgot. I'll read. Jovidashri. Okay. Jovidashri is here. Okay. Now Arushi is trying to push this gift box, but you are not able to. So Arushi is taking the help of Jovdashri and she is giving a helping hand. Okay. Now in this case, tell me how many objects were there? No? Okay. 3. So there is, to which direction it will go? To both of you should push. Okay. Now consider, I am taking my Jovdashri this side. Okay, I'm gonna take my Jovdashri here. Okay. Now what you are doing? Jovdashri is not helping Arushi. She is fighting for the gift box. No? They are gonna pull like this. I want the gift box. Teacher gave me this for me. Okay? Don't fight, but consider or imagine. Like you pull for a book, no? So just think that both of you are pulling for the book. So what force is this? They are opposite force. No? In opposite direction only the force is gonna happen. Not to the same direction. Okay. So teacher will explain this type example once more. Just now consider that the other one where Jovdashri was here, that is same direction force. Okay, same direction. But what is this? This they are pulling. Here Arushi will pull and here our Jovdashri will pull. So what happened that time? What will happen? Who is going to apply more force? Who is stronger? Jov or Arushi is stronger. Who is stronger will win. Okay, they will get the book or they will get the gift box. Okay, so force, important thing is its magnitude. Okay, if I am telling that Jov is applying 2 Newton force and Arushi is just applying 1 Newton force, who will win? Jov will win. Clear? Okay, so that is a type of force that we have, that is same direction force and opposite direction force. Okay, so that is just like a introduction I am telling. Now just before I heard someone telling that about friction. Now as a word meaning, what is friction actually? Is it good or bad? Is it good or bad? Friction. You might have heard in smaller classes, no? Good or bad? Yeah, Joe has written balanced force and imbalanced force and all. Okay. It's good. Why is it good? Can you give me an example where friction is good? Where is it good? It produces heat energy. Yeah, it produces heat energy. But why we tell on an inclined plane? So should my plane be softer or harder? Hard. Okay. So for example, just try to push a ball in a soft place. Soft means smoother plane. Okay. Just now you told me, no, there is an inclined plane. Inclined means what? There is a slope. Okay. So teacher will show you. Wait. How an inclined plane will look like? Okay. An inclined plane will look like this. Okay, understood? Now I am going to roll a ball this side. Understood? That rolling, where the ball is rolling on a smooth surface, what will happen? Will it move faster or will it move slower? Faster, no? So if there is friction, is actually what? Friction is something happens when you have a rough surface. Okay, that is an opposing force actually, opposing force. So we cannot tell that it is good here. Okay, in a smoother surface I need to roll a ball. So if there is friction, it will not roll smoothly. It will not roll fastly. Okay, so here the friction is not needed actually. But there are areas, okay, there are circumstances or situation where we need friction. For example, I am going to walk on a ice skating, or ice skating surface is very smooth, no? Very smooth, very sensitive place. Okay, I'm gonna walk with my smooth shoe, okay, which is not having that grip down. So what will happen? Or you try to walk with some stylish sandals. What will happen? What will happen that time? You can walk smoothly. No, you will tumble down, or you slide down, or slip down. Okay, so that time, in that cases, we need friction to make us walk. Okay, so why do we use that grip thing of that shoe to walk on the surface? Because it is producing some force. Okay, opposing force. That is called as friction, which will help us to walk. So how friction is gonna happen is, friction is coming from the surface where we touch. Okay, where we touch. So the force is coming from down. Okay, so the force, I will show you one picture. Okay, I will show you one picture now. Okay, now you will understand what teacher is telling. Okay, so I am going to push a box. Okay, the surface is down. So what happens when you push something? When you push the box, frictional force, that is an opposition force, will act back. Okay, so teacher told you to see in that video, there was an arrow, no? Backward. Yeah, that is friction. Okay, so when friction is gonna happen, friction is there everywhere. Okay, frictional force is there everywhere. That force will happen opposite to us. Okay, so I am pushing the box this side, means the frictional force will come from here. Okay, the frictional force will come from here. Now in this case, if it was not a smooth surface, if it was like a bumpy surface, friction will be more. Okay, now what will happen if friction is more? You have to push it harder. Okay, understood? If it was a smooth surface, friction is less. That time it will move faster. So all these have to be connected. So teacher will draw one thing and then you will understand. See, I will write the relation, how it will be. The force applied here, this side, and friction will come this side. Okay, opposite. See, pushing the box left side, and friction will happen. That friction should be exerted from the surface. Okay, surface where we are moving. So the friction is this side, and motion where it will be? Motion will be this side. Motion will be this side. So think that my surface is like this. a bumpy surface. Okay, now I'm asking you, if I am increasing the friction, that means if this is a surface, what will be the friction? If this is the surface, more. No, that means I gave an up arrow. That means the friction is more. Okay, so what will be the force we need to apply? What force? More force. Okay? Huh? So, we need to apply more force. Okay. Now, if the consider that my surface is a smooth surface. So, what is that friction? Friction is less. Okay, friction is less. For smooth surface, there is actually no friction. Friction means between our gift box or box and the surface, the friction is less. Okay, so it will go smoothly. So do we need to apply more force there? Do we need to apply more force? No. Arushi is understanding? No. Okay, just understand that. Just imagine that it is a rough surface with like this bumps. So I am pushing. I am giving a force. So I need to push like this. So friction more for bumpy surfaces, or you can just imagine hard surface, not smooth, hard. So hard surface, friction is more, force should be more to move. Understood? That is a relation. Okay. Now, in the other hand, if the friction is less, smooth surface, friction is less, whatever force we need to apply, smooth surface means I just push like this. So, I am just applying little force. So, less friction, less force, and it will move fastly. Clear? Okay. So, by this we will like wind up. Now, just we will recap whatever we have learnt, what all keywords we have learnt. Okay. So, teacher will write here. Okay. So, in this area itself we can write whatever we have learned it today. Okay. Pen. So, we learned about force, we learned about motion, okay, and we learned about frictional force, okay, friction. So, these three keywords we have learned, all are connected to each other, okay. So, this we will take it again and we will compare this particular frictional force that is going to happen in the previous video of that cycle. So we need to know why that arrow showed back. Okay. Okay. So have a great night. You have another tuitions again? No. I don't think so. Okay. So bye dears. So my class is okay, no? Okay. Very good. Good students. You can leave the class.